And ask you to present, okay?
Okay.
And we will have some hot water on the stage so you can drink.
Okay. Okay.
The Hong Kong Polytechnic University, PolyU, leverages its world-class academic and research excellence to develop innovative solutions for a more sustainable tomorrow. In July 2022, the PolyU Academy for Interdisciplinary Research PAIR was established as the university's central research platform, dedicated to providing world-leading, interdisciplinary solutions to significant societal challenges. PAIR is composed of multiple constituent research institutes and research centers. Each research unit focuses on a particular research area and is joined by researchers from various PolyU faculties, schools, and departments. These research areas broadly fall under three main themes, including advanced technologies and manufacturing, good health and well-being, and smart and sustainable cities. PAIR researchers develop new materials, systems, technologies, and techniques that support industrial modernization, upgrading, and transformation. Look into the factors and mechanisms influencing human health and wellness and develop evidence-based solutions. And generate smart technology-based solutions for making urban operations and services more efficient, connected, and eco-friendly. We particularly value impactful collaborative activities in research and scholarship. PAIR researchers pursue research collaboration at different levels. In addition to interdisciplinary collaborations within and between research units, PAIR and its units establish partnerships with industries, governmental bodies, universities, and other external stakeholders. With internal and external collaborations, we have successfully translated PAIR-led innovations into commercializable solutions and practical applications, and established joint laboratories and research entities with external organizations, driving scientific breakthroughs, innovation, and technology development, and socioeconomic prosperity. PAIR's research excellence and research impact have been widely recognized at local, regional, and international levels. Our research outcomes have been published in leading journals, including Nature and Science. Innovations led by PAIR researchers have won prizes at various competitions and events, including the International Exhibition of Inventions Geneva. Many PAIR researchers have been named among the world's top 2% most cited scientists in their own areas of specialty. Individual researchers have been selected to the National Academies of Science or Engineering and as fellows of professional associations, and have been bestowed with local, national, and international awards and honors. Harnessing the strengths of PolyU's research and world-class scholars, PAIR will continue our unwavering efforts in research and scholarship, knowledge transfer, and collaboration to develop impactful solutions that benefit Hong Kong, the nation, and the world.
Okay, good afternoon. My name is Xiaoli Ding Xiaoli, from Research Institute for Land and Space, PODU. It's a part of the pair. Yeah. Pair director, Professor Chen Qingyan, he is away from Hong Kong. Therefore, I'm filling in here to welcome you to this distinguished lecture. Very special welcome to our speaker, Professor Glen DAIGGER, and also some colleagues from outside PODU. I know, for example, some colleagues from Hong Kong U, some from HKUST, CUHK, and yeah, and also some other places. Maybe some of you here, I haven't met you. Today's lecture will be moderated by Professor Xiangdong Li. Professor Li is the Dean of Faculty of Construction and Environment. And also he is the Director of Research Institute for Sustainable Urban Development, RISUD. And also Director of State K-Lab for Climate Resilience. So without further ado, I think I will pass the floor to Professor Li.
Thank you. Anyway, Professor Glen DAIGGER and ladies and gentlemen, and so it's a really pleasure to see so many of you and come over full house for today's lecture. So before we going on, I have a very quick kind of introduction to Planter DAIGGER for about his kind of academic achievement, some of very much on the practical, like professional engineering, which kind of influence our water treatment for many years. Anyway, Professor Glen DAIGGER is an international recognized leader in wastewater engineering and sustainable urban water management, with a profound and long-standing influence on both scientific advance and professional practice worldwide. And he's a professor of civil and environment engineering at the University of Michigan, where his research and professional activity focus on advanced science and practice of biological wastewater treatment and solid separation, nutrition removal, resource recovery, and membrane-based processes. And beyond academia, and Professor DAIGGER has played an important role in shaping the global water sector through professional leadership and through about IWA like presidency and standard development and technology translation. And Professor DAIGGER is a fellow of the U.S. National Academy of Engineering, but also is a kind of overseas fellow of the Chinese Academy of Engineering, and as well as a distinguished fellow of International Water Association. And some of you may quite familiar with IWA, and the fellow of the Water Environmental Federation and the WEF. And he served the president of RWA from 2010 to 2014, during which he guided a strategic initiative on sustainability and global capacity building of water for water utilities and regulations. And Professor DAIGGER have received over 30 major international awards, including the Eddy Wastewater Principal Process Medal, the Golden Moscow Fair Award, and the Gas Cogen WWTP Operation Improvement Medal. His authoritative textbook, including the biological wastewater treatment and a manual on cause and control, so active sludge, bulking, forming, and other solid separation problem, are a fundamental reference in water and waste treatment. So without further ado, please welcome Professor Glen DAIGGER, please.
Thank you very much. It's great to see you who are here, and I know there are those that are online as well. You know, of the things that I've written, probably the one I'm the most proud about is the manuals on the causes and control of activated sludge, because I can walk into laboratories at treatment plants all around the world, and it's not on the shelf, it's on the desk. So that's what all of us want to do, is to not only create knowledge, but to create knowledge that people actually use, right? So I'm really pleased to be here, honored to be here. I look at the speakers that you've had, and to be speaking in the same forum is quite an honor for me. You see the topic. I'm going to speak a little bit about what we need to do, and then a lot about how we do it, just to give you a perspective. So this slide is the trends in terms of what we need to do, and then I'll go on to how we need to do it. So a high-level analysis of the global water situation indicates, first of all, there is no more environmental water. Anyone that thinks we're going to solve our water problems by going out and getting more water out of the environment is going to be very disappointed. We are overusing, in general, the surface and groundwater resources, first of all. And secondly, climate change, in fact, is reducing those supplies, as well as the quality of the environmental water. So, in fact, there are utilities that will need to replace what they believe today is their supply, because that supply is disappearing. Southern California is a great example of this, where they are investing tens of billions of dollars to convert their water resource recovery facilities, what we used to call wastewater treatment plants, to indirect potable reuse on a massive scale, to significantly reduce their dependence on imported water, which is diminishing. One example, but everything I'm going to talk about here is happening many places around the world, not just one example. Second, we have less water out of the environment, but water demands are increasing. It used to be population was what we looked at, but you know, we're kind of moving, at least the demographics tell us that we're moving to a more stable population. There's increased standard of living, the increased economy overall, which demands more water. But it's interesting, an observation is that over the last several years, the new industries and existing industries demanding more water. Think about semiconductors and data centers as just as an example of that. So how are we going to meet that demand? New water supplies will be provided by, I borrowed this phrase from the Australians, manufactured water, desal, reuse, things like that. These are the future water supplies. Third, the economic value of water exceeds the cost of service delivery significantly. People say, how can we afford water? Well, analysis after analysis after analysis says the broad economic and social value of water is about 5 to 7 times the cost of developing and delivering the service. 5 to 7 times. The challenge is that the benefits are more distributed, like enabling economic growth, health. There's a reason that Bill Gates, after he started to look at medicine, turned to water and sanitation, because it is orders of magnitude more cost effective than giving, pills to people. But it's difficult to access those revenue streams. That's the challenge, is accessing revenue streams associated with the value of water. The important thing to know is that the money is there. The money is there. It's about accessing it. And there are people all the way around the world that are doing that. It's a matter of looking at where we can develop revenue streams to help fund the good water service. And new technologies and practices are demonstrating that increased demands can be met without sacrificing the environment. That's the great news. We can solve these problems. We can solve these problems, but it's just not the technology that will do it for us. It's bringing the technology into the human and the institutional settings that are necessary to develop the mechanisms to actually deliver the service. So, but the pace of implementing new technologies and practices must accelerate. We need to bring these things into practice more quickly. So I'm an optimist. I'm an optimist. I know we can solve our problems, but we need to be working on quite a holistic fashion to do that. And that's really what I'm going to talk about as we go forward here. Hopefully I've stimulated a little bit of discussion later with these things. So for a long time, I've been talking about the water profession really just needs to do three things. I'm going to add a little bit to this, but I'm going to do the first three things. There are obviously three really big things. Why is there three? Because people can remember three things. You try to tell people 12 things, they don't remember them. So we're going to go over these one at a time. Number one, we as water professionals must fundamentally change our approach to water management to avoid water stress. Now, what's water stress? It's not on a good day. It's when it hasn't rained for what seems like forever, or when it's raining like crazy. Droughts and floods. Droughts and floods. What I'm going to describe here has been coined One Water, so looking at the overall water system and optimizing the overall water system. In China, the sponge city is I like that term because it's very evocative, right? On the not enough water, it's about a portfolio. It was actually the Australians in their millennium drought between the mid-90s and the mid-2000s coined this phrase. A portfolio is a combination of different things, each of which performs well under different conditions. If you're a financial person, you look for a financial portfolio, and this is exactly the same idea. So things that work well when you have plenty of environmental water, but also things that work well when you don't. You can read a lot faster than I can. You see the list here of things. Increasingly, water reuse is becoming part of that portfolio, and desal, because these are things that work well when when the environmental water is not so available. Get the idea, right? The combination under different circumstances. For flooding, the same concept is being articulated, different components. So traditionally what we've done, right, is we build pipes and swales and dams and dikes and so forth. Increasingly, we're supplementing that, making a system that includes natural systems. We have to get away from this idea of designing to a target storm because we don't know what it is anymore. Stationarity is dead. So the evolving approach that is being enacted in a number of places is not to look at designing to a given condition, a fully deterministic approach, but more a strategic approach. The strategic approach says when these flood defenses are defeated, where does the water go? This is where natural systems, for example, come in very well, that systems that you can flood return to service very quickly, and most of the time, they're providing other values. How do you pay for it? You recognize those other values. But also, spatial planning. This is a nice term for saying, let's move people out of the floodplains. We've built things in the wrong places, and we just need to move people to leave that room for the floods. So the Dutch were really the first to articulate this. They call it room for the river. So it's nice to have a phrase that kind of conveys this. And it works. The good news is it works. Eliminating biases. I said we have to change. You can read through here, but when you look at water supply and wastewater management, this is the traditional approach, right? The things that we've already done, or that we've always done. What if we flip this around and looked at least on an equal basis, reuse, because reuse solves two problems. It solves the wastewater problem and it solves a water supply problem. So you see how you practically think about One Water. Look at those things that may not be the perfect solution for a narrow part, but things which have more than one benefit. So you have to look at the overall value to cost, not just the narrow, but the broad value. So this is not so hard, but again, it's a little different than we're used to thinking. And in terms of, so turning now to the too much water, we are increasingly learning how to integrate these more distributed natural systems and so forth in with the pipes and so forth. Great area of continuing advancement in terms of both intellectual knowledge, but also engineering practice. That's number one. Number two, water management must become more resource efficient to sustain into the future. Resource recovery is a phrase that's often applied here. So what you see on the right-hand side is from the Stockholm Resilience Institute, one of their more recent assessments of where we are looking to overuse the sustainable resources of the planet. It's pretty simple. We got one planet and we're trying to use two or three. Obviously, that's not going to work in the long run, right? Now, when you look at all these things, each and every one of them actually are impacted by how we manage water. Even things like biodiversity and land system change, in many instances, just because there's a lot of places we're taking too much water out of the environment. So our view needs to become expansive in that regard also. Where are we damaging the environment by the way we manage water? And there are plenty of places. Now, let me describe what I've just added to this, because there's a practical economic aspect of this as well. You see that line there on this diagram and then the arrow back? For 100 years, the costs of all kinds of commodities, metals, energy, and so forth was constant. That's what's shown here are the relative costs of a number of things like ag materials, natural gas, metals, and so forth. Why was it constant? It's because we had plenty. In fact, the cost didn't go up in spite of inflation because we got better and better at taking it out. What's happened is scarcity. What you see is the economic impact and the turbulence that's caused by scarcity. If you're a water utility and you can produce the energy that you need to provide service, in spite of varying energy prices and spikes and so forth, you can cruise along and do your job. So there's a practical aspect of this as well in terms of managing water, extracting these materials. We're going to use some of them. They also can help us to finance as well. Now, we already produce quite a number of products. Here's what we do today. And this is being extended fairly quickly to a broader range of products. The good news is we have many researchers all around the world looking to expand this significantly. Here's one way that many are looking at it in terms of a pyramid of moving to higher and higher and higher value products extracted out of the water cycle. It's interesting, the higher value also are smaller and smaller volume. So folks are working on each and every one of these things. We'll see which ones come to bear where. One of the things about water also is that what we do here is going to has the same components, but it's different than what we do here because you fit it to the local setting. We also need to look at our practices. We're comfortable working on technologies in the laboratory and so forth. Source separation. What you see here is the distribution of organic matter, BOD. This is chemical energy. This is chemical energy. Nutrients. The nutrients are in the urine, as well as a lot of the pharmaceuticals, in 1% of the volume. The energy is in about 20 or 30% of the volume. Most of it is in gray water, which is relatively uncontaminated. Why do we mix them up? You asked me that during the discussion. We did it for some logical reasons, but there are logical reasons that don't apply anymore. And here also, part of this is working with people. So actually we can do all the processing that we need to do. So it's getting people comfortable. This is a urine separating toilet. And there are even improved versions of this now. So a lot of this is working with people to get this done. A recovered material is a resource only when it's used. This is also an important area of investigation because if we recover a little here and a little here and a little here, different utilities, different locations, we very well might not have enough to actually turn this into a product with enough volume, the right timing, and so forth. So a little story, I actually learned this. I actually had this idea from Mark Van Loostricht, but it really resonated with me because Mark said, well, what about milk farmers? What about dairy farmers? My brother just retired fairly recently. He ran a family dairy farm for 30 years. His milk had zero value on his farm. The reason he was able to support his family for 30 years was the fact that he was part of a co-op. In fact, this is a nonprofit that aggregated the milk from 100 families and turned it into products. So you see the kind of thing we need to be thinking. Just because you make a little bit of something doesn't mean it has value. So this is really, I think, about getting scale. And I think we have partners, both the larger utilities, but also the large water companies, and also the private sector can play a role in this. This is just bringing some basic business sense to this. We can figure this out. We can do this. We know how to do these things. These are kind of the physical things and so forth. We know how to do these things. So the first thing is to put everything on the table. Good American saying, right? Put everything on the table on an equal basis. On an equal basis, take the bias out. Then look in a given circumstance how to put them together into good systems. And a system can have centralized components, but also decentralized components. Decentralized components are ones that are slowly being added, and we need to accelerate the pace of doing that. If you're going to reuse water, the best thing to do is to do it on a more local basis, for example. Thing is, we have the technologies to do these today. So, and this is a little cartoon I put together a long time ago just to give you mentally what, these things can look like, particularly with these hybrid systems that combine centralized and decentralized systems. One slide specifically for this region, but distributed systems fit the form of urban development in Asia. These are just some photos off the internet and so forth, but you guys know this, right? These 6 or 8 or 10 or a dozen high rises, that's the perfect scale for decentralized water management at that level. So you got plenty of people to create economies of scale, but you don't have to move water long distances and so forth. This is a missed opportunity in Asia yet. So these systems, people start worrying about reuse. You can actually improve public health doing this well. You take less water out of the environment, which we're going to need to do. Reduce environmental discharges. People, they complain about increasing treatment to put it back in a receiving stream. They say, well, this water is too good to throw away. Let's use it. Let's use it. Reduced resource consumption. Source separation dramatically reduces the energy that's needed because you extract energy out of the chemical energy. You produce a lot of great water out of the gray water with a lot less energy. Very clear. Easier system upgrade in the distributed components. Increased resilience because you don't have points of failure. An enhanced urban environment, especially when you can incorporate natural systems. So these are the first two. Number 3, the human right to water and sanitation must be extended to all. I speak here as an American that there's a tendency to say, well, this is about people in developing worlds, developing countries. Even in the U.S., we don't do a good enough job of this. The human right to water and sanitation, what you see on the right-hand side here, is a diagram out of the manual that the IWA produced when the UN adopted the human right to water and sanitation. And it shows you the identified components of this. And I want to highlight these two. Sufficient quantity, safety. These are things that we know how to do. This is one of the challenges here. They're solutions, though. So again, returning to the benefits of effective water management, the issue is that from an affordability perspective, the benefits are distributed. When we try to pay for all of these things out of user rates, you can get to the point where there are folks that just can't afford it. And does everybody have to pay the same? The answer is no, but this becomes a barrier in many instances. It means there's going to be the need to subsidize some users. It's that simple. Can the cost structure reflect the ability to pay? The answer is yes. Plenty of examples around that, but we just have to think creatively about our cost structures. There are numerous approaches that are available to address affordability. If you're in a developing country, the challenge is building infrastructure that has taken the developed world to build, taken 100 years to build, and you want to pay for it with 20-year bonds. right? This is not complicated. We tend to, financing tends to pay back over 20 years. You're trying to do 100 years worth of work and pay for it in 20 years. This is where you get into tariffs, taxes, and transfers. But also, there's some creative things. DC Water in the U.S. was one of the first to do this. They're extending their sewer system. They sold 50-year bonds. So this infrastructure is here for at least 50 years. We'll pay it back after 50. So, and they sold those bonds. Understanding the role of the private sector. There's a lot of misunderstanding here. So the private sector doesn't fund this, meaning pay for it. Government and users have to pay for it. The private sector can provide financing, which is they're lending money, and they can bring efficiency and so forth. A lot of the failures of private approaches have failed exactly because of this lack of understanding. So when I was at C.H. Stubb Hill, we'd see RFPs, and many of them we'd look at, and what we said is, oh, these people want us to pay them to treat their sewage. We can't do that. Private sector can't do that. I would commend to you, this could be a point of discussion as well. This is Clayton Christensen, who is really a major thinker about innovation. This was his last book. He passed away a few years ago, looking at infrastructure in Africa in particular. But he said that the mistake is to build infrastructure and then assume that it will create economic growth. You create economic growth and then provide the water infrastructure that supports it. So you develop the revenue to pay for it. So it's a real simple, but this is another thing. Proactive community engagement also develops credibility and forward motion. This is where a lot of utilities, where you have utilities that are not very effective, these are the things that they don't do. What I'm showing you here is a very nice document. This was collaboratively done with the U.S. EPA and some other partners. This is looking specifically at potable reuse. If you're going to look to develop a potable reuse project, the things you need to do. But I think this is good general advice in terms of effective utilities that are well positioned to advance the things that we're talking about. So utility reputation. Utility reputation turns out to be crucial in this. How the public thinks about the utility. Creating and executing a comprehensive strategic communication and build trust and credibility. If you're going to do, one of the messages of this document is that if you're looking to potentially do potable reuse, you've got to start 10 to 15 years early, developing the credibility and communicating with your public. An external expert body to give credibility. Access the community needs. What does the community care about? I'll tell you that probably don't care about water. One of our problems is trying to get them to care about water. You find out what they care about, you will find that good water management helps them to get it. So we stay in our own heads and we don't get in the heads of those that are going to pay the bills. Find out what they care about. I will guarantee you that you'll find a way that water contributes to that. Take an integrated water management. So One Water, it's not about selling a piece of it, but how does it fit into an integrated program? Comprehensive financing plan. Look for those sources of revenue. You'll find them if you look. work with, and again, this was the U.S., so it's the state agencies, but it's really senior government. So keep them engaged and informed. Introduce potable water reuse, but this can apply to anything, but as a portion of this overall plan. Don't sell it. Help people come to understand that it'll work, and foster collaboration and integration among the various utilities. You don't have to be a water cycle utility to do this. You just need to have relationships with the other utilities. People that do this are successful, and there are many that do this, but not enough yet. So those are the three things. Let me come to some other things that I want to put on the table. So natural systems, I've already talked about for flood management, but natural systems provide a diverse array of services. So water supply, certainly. Protected watersheds are something which are all around the world, both because they secure the water supply, but also quality. Water storage, in various fashions. I've already talked about where do you flood in urban areas and so forth. Water conveyance and retention, so restoring streams. And the good news is everything I'm talking about, the pace of implementing is going up. But all of these are services that we get. Some of them related directly to water, some of them related to other things. So water treatment, land stabilization. So both erosion control and when you're looking at groundwater, avoiding land subsidence. Temperature regulation. Temperature regulation, pretty important in urban areas. And physical health. Recreation. We don't tend to think about that, right? That's a real benefit. And mental health. It is a proven fact that if you are a patient in a hospital, if you can look at out your window and see a tree or something like that, you get well faster. It's a proven fact. And communities and families using the natural environment that's there, think about that value as well. So what might be the components of a resilient water system? Resilience is something that we talk about. So integrated rainwater, stormwater management system. We've already kind of introduced that. Here's some of the, but again, it needs to be integrated with city planning. Why do the utilities need to have a great relationship with, senior government? Well, they need to be at the table when planning is done. Portfolio approach to water supply, and I've already made the case for reuse. Reuse is systematically more potable reuse is systematically more cost-effective and more resource efficient than seawater desalination. It's very simple. 35,000 pushing water out of something with a TDS of 35,000 versus pushing water out of something with a TDS of 1,000. It's the same technology, but there's just that systematic difference that'll always be there. And the wastewater is always there. Resource efficient, I've already talked about this, but adding some things, so continuous restoration of the natural environment, making that part of it, looking for those opportunities as components of the system, recognizing the broader value that they bring as well, and looking to bring that at least into the discussion. Flexible and adaptable, because we live in a changing world. As we put things in place, think about the different ways they could be used in the future. I've been designing systems for over four decades. I have redone twice some facilities I was involved in early in my career, we always did something different with them. I've learned to think about when I'm designing something, to think about not is the perfect way to use it for the current purpose, but how can things be used differently? And if you think about it, it's amazing what you figure out. If you don't think about it, you miss an opportunity. Credible and capable utilities. And this is, to a certain extent, this is where the rubber meets the road, if you will, in terms of where things get done or they don't get done. The long-term vision, but then within that vision, doing the things that are needed today to provide the service. It's not either or. You have to know where you're going and then take prudent steps to get there. So how do we achieve systems of this type? I will tell you that there are many utilities around the world that are doing this very well. So what are some of the tricks of the trade for them that get them there to do this? It starts with developing a vision, but it's a vision, first of all, that aligns with the physical realities. So given the circumstances, and a vision is not prescriptive. What are the things, given the water that's available, the geology, the topology, if you have existing development and so forth, what are the things that are possible? And given what's possible, open up your mind to how that can be, how those constraints, those are constraints, but what you can do within those constraints. Always with the objective, though, of the things that are listed there. Managing the storms and the floods more effectively, increasingly effectively, because what we have now in terms of intensity and duration of storms, it's going to become more. It will become more. We know that. Water supply. How can we increasingly use what we have to increase our water supply, even in circumstances when the natural water is being reduced? We can do this. So the vision is that integrated picture and the components that we might want to deploy and the options that we have. And I've worked with utilities my entire career. And if I think about the executive director, the CEO, the top management of a utility, it's kind of like they're playing a game of cards, because they're making decisions every day. And those decisions have short-term impacts, they have long-term impacts. What I'm talking about here is dealing them the best hand. Because it's how, in the long run, it's how the game is played that creates success. The technologies and the things like this, these are the cards. The relationships with the community are some of the cards. The relationship with senior government. So you can go in and know how to, and go down and sit down and talk to the people that you need to and have honest discussions and so forth. These are some of the cards that that the senior leadership of a utility has. The more cards they have, the better they can play their hand. So vision is part of it. Engage with the community. So I'm reiterating some things, but really what I think are some of the key points here. So engage with the community. The first is to understand what the community cares about. and then how good water management aligns with that. I'll tell you a little story. So I mentioned the millennium drought, the 10-year drought in Australia, which ended in floods. Not Australia. Australia is the land of droughts and floods, right? That's what they say. In Western Australia, it didn't rain. Their drought went on. So Sue Murphy was the CEO of the Western Australia Water Corporation, Water Corp as it's called. Basically provides water service for the western quarter of the whole country. Sue, she became the CEO kind of towards the end of the drought, but the drought was continuing in Western Australia. She said, you know, I talked to my senior technical people. I said, well, we got all these solutions. We don't know why people won't do this. They had it all figured out, but they didn't know why people wouldn't do it. Sue started a planning process, the title of which is this: what are we going to do if it never rains in Western Australia again? If you know what to do under the worst case scenario, then you're prepared. The other thing she did is for the first 6 months, they didn't do much technical work. She said she took her senior managers, they put together some kiosks, and every Saturday morning they went out to a shopping center or this, put up their kiosk and just listened to people. Said after 6 months, you'd be amazed. They started to understand what the community cared about, and they were making the connection of water to what people care about. That's really a secret here. Maintain and expand collaborative relationships with senior government. I've already talked about that. Identify options that provide multiple benefits. So again, don't just narrowly solve problems within a portion of the system. Look broadly at the whole system, and always say, okay, what could we do here that could solve 2 or 3 problems? And then you just evaluate. I mean, we're good technical people, but evaluate it and look for the value to the cost. Move forward pragmatically, step at a time, but consistent with the vision. Never forget the vision. Learn and adapt. We learn all the time. We learn by thinking. We learn by doing. Every time you do something, you learn something. Take that on board and build on successes. So it's pretty straightforward. It's actually pretty straightforward. So I'm going to end with a little bit of Americanism. I'm obviously an American. So what you see on the left-hand side is a baseball player, played for the New York Yankees, Yogi Berra. Not Yogi Bear, the cartoon character. Yogi Berra, this is his real name. And Yogi Berra, he was a catcher. He was one of the best baseball players of his era, but he was known for the wacky things that he would say, that when people figured out this is pretty wise. So they're called Yogi Berra-isms. So I'll share 3 with you as I come to a conclusion here. So you've got to be careful if you don't know where you're going, because you might not get there. This is about vision. Yogi understood this very well. So you got to generally know where you're going. Here's one I love. Being in academia, I see people that don't understand this. In theory, there's no difference between theory and practice. In practice, there is. Half of the learning that you do is when you go out and do something. So it's important to go and do. You want to think about what to do, but then go and do it. You're going to learn something. And Yogi said, the game isn't over until it's over. So you might be down 3 runs going into the 9th, but you can still win. In water, the game is never over because things change around us. The climate changes, the economy changes, the people that we're serving change, the needs change. We're always learning, growing, and adapting. So the game is never over. So with that, I thank you very much for your time and attention, and I'm looking forward to some good conversation now. Thank you.
Okay, thank you very much, Glenn, for the really inspiring talk, I have to say. So as a young faculty member working on the wastewater treatment for until this year, 10 years. So actually, when I sit there listening to your talk, I'm still taking a lot of notes. So it's not because I know I will be moderating this discussion. It's really helpful for myself. So it's you see in your talk, you said for one particular technology, it's really like one card we are playing with. But from your talk, you put all of the cards on the table. So it's really, really inspiring for me, I believe also for everyone here. So in the next 30 minutes, I will be moderating this Q&A session. And as a moderator, I think I have the privilege to ask my question first to you. And also I'll give some time for you guys to think about your questions. So my first question to you, actually, when we were back from the airport last night, on the taxi, you mentioned to me last time when you visited Hong Kong, that's many years ago, right? And you mentioned you encountered a very serious typhoon and the conference you attended was delayed. And I mentioned to you, so in recent years, actually, this kind of extreme weather becoming more and more frequent in coastal cities like Hong Kong or like Brisbane in Australia, where I used to live. So this is really some consequence because of the unstoppable climate change. And also you mentioned something in this aspect during your presentation. So my first question for you today is, so for under this big umbrella of climate change, which we basically cannot stop or prevent in the near future, so what's could you please share some of your insights into the potential impacts of climate change to the urban water supply and also to the urban wastewater management? Probably some of this impact already happened. Probably some of them will happen, which we should pay more attention to in the future.
Yeah, so certainly part of it is increased flooding, right?
Yeah.
So what we're seeing is increased intensity of rainstorms and increased frequency of more intense rainstorms. So, I live in southeast Michigan in the U.S. The southeast Michigan. The metropolitan area around Detroit is about 4 million people, kind of small by Chinese standards, but substantial by U.S. standards. It's an old area, so half of their system is combined sewers, and the other half is, the newer portion are separate sewers. But the combined sewer system was designed for a 2-inch rainfall. Not very big. In the summer of 2021, they had one of these storm systems go through with some very localized, very intense cells. So it wasn't the whole area, but they had areas that received 6 to 8 inches. So the part of this is understanding that we don't know what's going to happen. So it doesn't mean that we abandon the computational tools we have and so forth. But what it does mean is thinking about when what we have is defeated, where is the water going to go and what can we do about it? So again, that's the idea of the portfolio. So the Dutch were some of the first to do this very systematically. I think we all know about the challenge that they're faced with. So they think strategically. So also part of it is, well, we could do this here, and rather than say, well, okay, we're going to design it for the 100-year storm, you say, well, how big can we make it?
Yeah, right.
So it's bringing, along with the analytical side, a strategic thought process. So it's admitting that we don't know. So what are the things that we can do, and how do we put those pieces together to have a system that will perform at a higher and higher level, and also realize that we don't have to do everything at once. So that's the kind of thought process that we need to bring. Is to understand that we don't live in a deterministic world anymore, and to bring a strategic along with an analytical thought process. It's interesting. In engineering education, we really teach the deterministic side, right? And there's some people that think, well, we can only do it this way. If you look at how people make decisions in their everyday life, they make decisions strategically along with analytically, right? So human beings can do this. We just have to give ourselves permission to do this, and then do the math to understand why we're doing certain things at different times. Same idea applies under the drought scenario. So I think that treatment of wastewater and discharge will go away. So if you look at actually what the environment is telling us today, that we're not treating to a high enough level today. So there are a lot of places that are getting to look at how can we treat to this level and then just throw it away? Don't. So in the EU, the new Urban Wastewater Treatment Directive, they're making their nutrient limits more stringent, but they are formally, they are beginning to formally require physical, chemical, biological processes to remove trace constituents. They're on the way to producing potable water.
Yeah.
People aren't stupid. When you get water of that quality, why would I throw it away?
Yeah, thank you, Glen, for the sharing. In the last, you mentioned for EU, they have different strategies for the wastewater management nowadays. So actually, I asked this question to Professor Pedro Valores last year when he gave the lecture in the same room here. So I'll ask the same question to you. So, Professor Pedro, he's working on the material nanotechnology application in wastewater management. And well, for you, I think you're more working on the biological part before. So my question is, for the biotechnology, in terms of wastewater treatment, the biotechnology and the nanotechnology, which one do you think we should pay more attention for the future wastewater treatment?
I don't think we should presuppose what we're going to learn. Again, I talked about the putting these systems together, you put everything on the table. Put everything on the table.
Yeah, depends on the objective. Yes, right.
Yeah.
Okay.
This is where a good fundamental understanding of science and engineering comes in, because you can also, that good fundamental understanding gives you some understanding of what a given science, a given technology, and so forth, what it's likely to be able to do and what it can't do. Now, you shouldn't take that as a given, but if you start thinking about nanotechnology, the question is now, how does this function? Given how it functions, what is possible to do with it? So the good engineer knows what we've done, knows what we can do, knows why we do it, but also understands functionally how it functions.
Yes, right.
That functional understanding starts to inform you in terms of, what it can do and maybe what it can't do.
Right, thank you. Okay, so now I'll open the floor for questions from the audience. Any questions? Yes, all right. So please identify yourself first, because we have the online recording for education purpose.
Thank you, Tom. Yeah, Haran here from I'm Haran Dong from University of Hong Kong. Thank you, Professor DAIGGER, for very inspirational talk. I myself work on wastewater treatment technologies, and so your talk is sort of really going out of the box on a very high level. I'm particularly interested in your opinion about decentralized wastewater treatment for regions that has high density, like probably Asian, like Hong Kong. I think that sounds like it is a very, it has good potential. But what do you think of the drivers, particularly why would people want to shift from centralized to decentralized? What you think would be the main drivers, and how particularly economics would that make sense? And also, do we need probably management restructuring to enable such to happen? For example, do we need a more free market sort of competition to enable such? I would love to hear your thoughts. Yeah, thank you.
So let me see if I can keep the questions. If I miss one of your questions, just please remind me.
Yeah.
But the first thing is we should do things for purposes. We should do things for purposes. So one of the real advantages of decentralization is that you can produce reusable water right where there is a use for it. So so as we look to, the alternative is to convey the wastewater to a centralized location, treat it there, but then to put in another piping system to distribute it back. And the one thing that we've demonstrated with our water systems, water and wastewater systems, the thing we have the biggest difficulty maintaining over time are our pipes. So the first thing is, if you're going to do decentralized treatment, look at how you can reuse the water. Also, I am a proponent of source separation, which becomes much more feasible at these high rises are perfect for that, right? So you inherently with that create opportunities to reduce energy and to recover materials. So there are a lot of positive benefits of decentralization. So you shouldn't do it just because to do decentralization. You should do it for benefit, but the benefits are there. So it's obvious that decentralized systems need management. So a phrase that has developed in different locations, but a responsible management entity. So just like the utility that's providing the centralized service, you need an institution that is capable and so forth that manages that. Obviously, if you are putting in place several decentralized systems, you have the opportunity to, because of economies of scale of serving multiple sources, for businesses to develop that can do that. And this is indeed happening. One of the examples in San Francisco has mandated that for buildings of certain size that they must incorporate reuse. There's a whole industry that's developing there because now, this is just simply a requirement so they've created a market for it by doing that. So it could also be the centralized utility that also develops that as a separate business, if you will. They're obviously going to have to, whether it's private or public, they're going to have to be paid for that by the users of that system. So doing all of that is the idea is relatively straightforward. It is happening many places around the world. But yes, you just can't put the system in and assume that it's going to function. It needs operation, maintenance, and ongoing replacement.
Thank you so much.
Thank you, Horan. Actually, I can follow up on this particular aspect. So I think in terms of the economy, definitely the decentralized system probably would be one of the options for the mega city like Hong Kong. That's in terms of the economy. But in practice, actually, in addition to economy, we need to think more. Definitely, like you say, the management, how to manage all these decentralized system safely. That's definitely very important thing. For example, in Hong Kong, we have the harbor area treatment, which transports nearly all of the wastewater to Stonecutter Island, one particular treatment here for centralized treatment. That's really one of the reasons for that is to actually to protect the community from this wastewater kind of. Yeah, we have people from drainage service department here today as well. So yeah, definitely that's one of the reasons we're doing that way. So yeah, definitely, yeah. But I also agree with you, decentralized this treatment would be considered in more scenarios in the future. Yeah, yeah. Okay, any other questions?
You're still building in the new territories though, right?
Yes, actually, yes.
You're building it. You have the opportunity today.
Yes, yes.
You're building in the new territories. You're building these high-rise buildings and so forth.
Yeah.
So the half of the learning occurs when you do it. Go get a pilot project. Go do it someplace. Have a backup of the centralized system. But learn how to do it and then replicate it. That's how, there's a tendency for people to think about everything like mass product goods that get to, when you sell millions, tens or hundreds of millions of units. In us, it's a small number. So a lot of the development occurs when you do it. But we have to go do it to have that learning.
Yeah, yeah, thank you so much. So any other questions?
Thank you, Professor. It's been a very interesting talk. I am a honky, several generations in Hong Kong. I also worked extensively in my younger career days in Singapore. These two places have perhaps the largest city population by size known internationally. And both cities have the same problem. We and also Singaporeans don't have their water supply. Can you comment on the water supply and treatment of these two cities, and how would you compare that with the general world trend? Thank you, sir.
Well, Singapore had the benefit of a secure water supply. In a sense, they still do with the contract from Malaysia. So it's very interesting. There was a study done about 35 or 40 years ago that really portrayed the system that they have now eventually put in place, but said, you know, that the technology is not quite here. They, of course, started the journey to new water and desalination and so forth really in the early 2000s. So they benefited from the fact that, in particular, membrane technology had and allied technologies had evolved to the stage where it could be implemented at that scale. But Singapore really has, as I talk about, and many people talk about, a one water system. They have put that system in place really over the last 25 years or so, and have had the benefit of, when they started to do it, that they still had the two contracts with Malaysia, so they could pace it. That was an advantage for them. Hong Kong, Hong Kong was a larger water demand much earlier. So the innovation in Hong Kong, of course, was seawater, right? That was the innovation. Is the
some incineration plant, but that was
seawater for toilet flushing, right? Seawater for toilet flushing. Certainly one of the few places, but certainly at the scale that Hong Kong does it, certainly the largest system in the world using seawater. That low for freshwater, though, Hong Kong is the vulnerability for freshwater, of course, for Hong Kong is is water coming from the mainland, which is increasingly polluted and of fixed supply. So when you start looking at manufactured water as the next solution, it's desal and reuse. So the other difference between Singapore and Hong Kong is that Singapore has been able to put in reasonable fashion the full cost of water service into rates, whereas Hong Kong government has not increased rates anywhere near the rate. So obviously, what Hong Kong is doing gets paid for, but not by the rates. So it becomes a bit of a different decision. Let me go a step further, though. The apparent simple thing for Hong Kong to do is to build desal, particularly as you look at, again, in the new territories, reuse should be a bigger part of it, because the effluent that's being discharged into some of those, not into Victoria Harbor, but into some of those upstream waterways is causing environmental damage. How do you pay for it? You create a water supply. So I think part of the future for Hong Kong is clearly reuse, and doing it in a paced and learning fashion, but again, not technocratically. You guys know much better how to communicate with the with the community and with senior government and so forth, but that process needs to be expanded and accelerated, the people process.
Okay, thank you, Glenn. Maybe last question, Professor Zhang.
You can.
Okay, thank you, Professor DAIGGER. Yeah, thank you for your insightful lecture. We learned a lot from it. I'm Tong Zhang from Department of Civil Engineering of Hong Kong U. And I believe, the principle you shared with us about global water management and in general can be applied everywhere. But we know that the water system is region specific or country specific or even city specific. And could you please share with us about your insight about how we do the water management in the developing area instead of like Singapore, Hong Kong, this developed mega city? Yeah, I believe there could be quite a different priority of the list when we implement the water management in middle and income countries. Please, thank you.
I find Africa to be instructive. You look at the centralized systems that we have today. They developed, of course, in the industrializing Europe and America, right? So I made the comment before that there's a reason that we have the sewer systems that we have. Well, they actually started as drainage systems. They started as drainage systems before we really thought about pollution control. So we built these big, and the reason we have started off with combined sewers, of course, is we built these drainage systems that had to handle, when it rained. And so you had these big pipes. Oh, we got this sewage. Oh, we got pipes. Let's put it there. Because we didn't treat it. So there's a reason that we have what we have. The question is, does it apply anymore? Africa has tried and failed to put conventional systems in place, and it's been a failure because they could get funding to build it, but they didn't have the revenue stream to operate and maintain it. And in fact, they could get funding to build a treatment plant and not for the sewers to bring the wastewater. What's happening in Africa, in many places, is not collecting all of the fecal matter and urine and drainage water, but managing the fecal matter and urine separately. That's the system that's actually working in where it is functioning and functioning well in Africa. Comes back to this idea of build what is most important, in this case, from a public health perspective, build what is most important that you can support with the economy that you have. So it is actually what was done in the industrializing countries. So built pieces of the system as it goes forward. So there are those that say that even if a centralized system is the ultimate point for Africa, they won't have it for 50 years because they just don't have the ability. The book from Clayton Christensen, it was very interesting. I knew what was going on in sanitation in Africa, but reading that book, what they're doing is they're building what is most important, what creates the highest value, but that they can afford and institutionally support. And then they'll go on from there.
Okay, thank you very much, Glen, for the sharing, and also thank you everyone for the engaging discussion. I think we're running out of time, so we have to conclude this Q&A session. Please join me to thank Professor Glen DAIGGER once again. Thank you.
Yeah, I'm sure you have enjoyed the talk and also the conversation as much as I have done, I guess. So in appreciation of the excellent talk, Pear has prepared a small souvenir here. Yeah.
Thank you. Mm-hmm. We'll do what you tell us.
Clear instruction.
Thank you very much. So now. Oh, sorry. Kill down your attack. Thank you for the process infection. Thank you.
Thank you very much. Thank you. Thank you all for coming to this lecture. Yeah.
Group photo.
Yeah, I think some of the guests maybe you can come to join us. Yes.
You join us to have a group photo. So last one, our audience we would have another group photo as well.
I need to do something to say something about Hong Kong. It's like most critical area.
Yes, yes. Yeah.
Can I have one on this side?
Yes.
Okay.
Balance,
And then
yeah.
try to
Okay.
keep the frame more vertically so to avoid the. Okay. Okay, everyone, please look at my camera. Smile. 1, 2, 3. One more. Okay, thank you.
Okay, thank you. So everyone from the food, we can take a photo there. Yeah.
One of the
Whatever.
Up to you.
Oh, yeah.
Okay.
You can try. Whatever. Yeah.
I happen to be still serving as the president of the whole engineers.
Can we
for the
back to the seat where our photographer will taking a full house.
Okay.
Yeah.
Okay.
Thank you.
So,
Good.
can you guys please fill up there? Okay, so everyone that you want to be included in the photos, you have to come on the corridors. Please, thank you. If you want to join the photos, please move to the corridors on both sides.
That's how my life.
Just tell me what you want me to do. Best of my ability, I understand and execute. That's my outcome.
That's pretty advice.
There's certain things I
Yes.
just never understand.
Yeah,
No matter how hard I try my best.
the simple and instructive.
Okay, okay, everyone is ready. Okay, please look at my camera and smile. 1, 2, 3. One more, 1, 2, 3. And a heart or like. Thank you.
Thank you. Thank you.
Okay, thank you very much.